Okay. Welcome everybody to the second seminar of our fall seminar series. We are pleased to have Jones. We are pleased to have Dr. Nishith Pathak with us today. Coincidentally, he is also one of our own. So we have second speaker who has strong ties with the University of Minnesota. Dr. Pathak received his PhD in the computer science department at the University of Minnesota. And I found out that he went to the best college in India called IIT Delhi. Yes. Right? If Chris was here, they debate, but since he's not here, I can take the credit. Yes. Okay, and so Nishith has a long background in working on machine learning problems and applications in gaming industry. And he has worked on this, especially in Wargaming, which is one of the actually, it is the creator of one of the most popular games in 2015, online games, yes, called World of Tanks. And he has very interesting things to share with us about engagement, customer engagement, and use of machine learning tools in customer engagement. Absolutely. So without further ado, let's welcome Dr. Nishith Pathak. Thank you.
Thank you, everybody. It's a pleasure to be here, talking before all of you. So as Dr. Mani mentioned, I have an extensive background in working with online games. I started working with online games data back in 2008. So it's been a while. I've had experience working with building machine learning models, facilitating various processes in a game's life cycle, from planning all the way to deployment and maintenance. And I want to share, today's talk, I want to share I want to share the world of machine learning in online gaming with you guys. So, you could broadly divide this talk into two parts. The first part, I'm going to focus a little on user experience in online games and how machine learning fits into it. And then I'm going to talk over a couple of problems, interesting problems that, we recently worked at in Wargaming, which kind of fit into the whole framework. So let's see. Okay. So this is my introduction. I guess I don't need to go over it again. We've already been through this. So, but I do want to talk a little bit about World of Tanks. So World of Tanks is, they specialize in building player versus player games that involve military vehicles. So, they have a bunch of games under their World of Games umbrella. You have World of Warships, World of Tanks, World of Warplanes, and World of Tanks is kind of their flagship title. And you can find the game on consoles, on mobiles, on PC. It's all over the place. You even have trading card games and merchandise. It had a very popular time. In 2015, it was one of the leading online games. And just like every game, over time, the audience decays, and now you have other new games which have taken over the mantle. But no matter what game, there are certain problems that are common to all online games, and we're going to be discussing them today. So I want to first start off with talking about online games and looking at them as from a data science perspective. So when you look at an online game, one of the things you need to understand that this is a complete universe, an entire ecosystem which has a bunch of people participating, interacting, they're working towards these goal-oriented activities, working towards objectives in the game. And one of the cool parts about online games is that everything is observable, right? Unlike the real world, you don't have to work with partial information. You can record every single observation. We have the ability to do it. And a lot of gaming companies do collect this information. They try to collect as fine-grained data as they can, right down to individual actions taken every other second by the players. So the real question is, as a data scientist, how can we use this data? What do we do with it? Because there's going to be a huge amount of it, right? You have hundreds of thousands of users taking actions every second in this game world, right? So how many of you guys are familiar with online games? I should probably ask that. Not many people, is it? So, okay. So a few people in the audience, quite a few. But the idea behind online games is you have this entire virtual world, and you can create your avatar or your character. And you use this through this avatar, you can participate in this virtual world. And you're going to have a whole bunch of other people with their avatars too, right? Traditionally, games used to be a very single player oriented experience, right? You go to the store, you buy your game CD or your Nintendo cassette, you come home, you plug it in your console and you play it. And, you discuss it with your friends, you discuss the achievements, but it was the community side, any social aspect was completely, you were on your own for that, right? As far as the game developer was concerned, they made the game, they sold it to you, and their job is done. Unlike today's online games, which is very different now, it's a completely different landscape. You now have developers that want to make a game and build communities around them. They want games with communities that can sustain for years. And the idea is to not just build a game, but to build a complete experience for the player, right? You have your game, but then you have a whole bunch of other things around it. You have the social aspect, you can make friends, you can engage with them in conversations. There's people try to get, the games celebrate events, right? You have Christmas events, you have Halloween. So it's a lot more involved, I guess, people, they try to get the user engaged as much as possible. And which brings me to one of the key problems, one of the key things in online games, which is user experience, right? At the end of the day, a game is about its experience. You have users who participate in the game, and then the key question is, are they having fun, right? Any game, any entertainment, you want to know, is my audience having fun? And that really is the first question that feeds into everything else that you're going to do. Any decisions you make about the game design, about the virtual world, any support you build, right? Everything is based on this one central question: what is my user experience like? And I want to point out that, in the gaming domain, when we talk about user experience, now there are many factors that feed into this, but we can broadly divide them into these three categories. The first category is gameplay challenge, right? This is about how much the game challenges you. Is the challenge right? Do I feel sufficiently challenged? Is it too difficult? Is it too easy? Right? So if I look at it in detail, the real question is, what is the right amount of challenge? When do I reward my players? How much should the reward be? Right? You want skill estimation. You don't want new players playing against or with the veterans. That causes frustration, right? Because they're on a different level in terms of skill, in terms of their knowledge about the game, right? You want newbies to be matched with newbies. You want the hardcore players to be matched with the hardcore veterans. So you want a situation where everybody is having fun, even though you have a very heterogeneous population in terms of skill, in terms of their preferences. And that really is the challenge in user engagement. So over here, we're talking about how much is the user skill, what the challenge should be like, how much should they be rewarded. And there's a lot of psychology research out there, but ideally you want users to be in what they call a state of flow, which is where the challenge is just right. They feel like they have achieved something, but it's not difficult to the point where it's frustrating for them. So the next important point I want to talk about is the social experience of a game. Now, online games today, the social experience is a very important part, right? This happened with Web 2.0 in the mid 2000s, where everybody was talking about friends lists, there was social support, you have voice chat, you have chat messaging. It started off with the explosion of social media with Facebook and Friendster and MySpace, all those old school social media websites. And eventually it evolved into Web 2.0, where, in 2022 now, almost any online platform, it needs to have social support, right? It's rare to find, at least in the gaming domain, it's very rare to find apps which don't have support for communication with friends. You typically have mechanisms to link your social media accounts, you can chat with players, you can voice chat with them. So this providing all this, this infrastructure to enable players to build communities, to engage with other players in a meaningful manner. This is now a very important aspect of any online gaming experience. And finally, this is probably something that, the traditional gaming community will relate to the most, which is the actual game environment itself, right? How do you how much do you like the game world? Some people like cartoony graphics. Some people like realistic stuff. Some people like aggressive military shooters, right? Some people like Minecraft, like base builders. So there's a huge amount of variety in what the nature of the game world and what it's offering you. And apart from, you can't do much about somebody, if let's say you have a shooter, a first-person shooter, a game where you're shooting people, and then you have an audience member who really likes base building, Lego-like games. You can't do much to win that person over, but you still have certain obligations, right? You don't want any game-breaking bugs. You want a nice and intuitive and easy to use user interface, right? These are basic UI and UX concepts that have to be implemented well in any game. So a lot of these, you have the price model. So you have the challenge, you have the social experience, and then you have the actual game world itself. And almost any user experience factor can be put into one of these three categories. And that's really what improving user experience is all about. It is trying to find out what improvements I can make in each of these three things, to get people to enjoy the game more. Right. So as you can imagine, this is a fairly non-trivial problem. And in most gaming companies, including Wargaming, we usually have a really large team with a whole bunch of sub teams, and each of them are focusing on different aspects of user experience, right? And user experience is something that informs every decision throughout the game development cycle. The market research, the actual development, where the lead designer is deciding on the mechanics of the game and the developers are implementing them. And then finally, when the game's released, you have the game maintenance part where you are judging the response of your audience. You're trying to improve the game. You're trying to make it better. You're trying to fine tune it, building communities around it, right? So the real question is, how do we do this better with machine learning? Essentially, that's really the core question as data scientists we need to ask ourselves. So if we briefly touch upon what traditionally has been the approach in the gaming industry, it's been the classic style where you rely on very experienced game designers and game developers. These are people with, over 20 years of experience building games. They have a very strong idea of what people want, what challenges people, what kind of rewards people would like to have, right? So they use their experience to design the game, to design the different mechanics in the game. And of course, you always have classic A/B testing. A/B testing is something that gaming companies have heavily relied on, and they still do. It's your classic A/B testing. You have two groups of users. You have your control group, you have your target group, and you run your experiments and see, does a certain hypothesis work or not? And you can use those to inform your decisions around various things, right? People use it for pricing models, for how to design the marketplace. People use it for game mechanics. They use it to judge game balance. They use it to judge UI design. There's so many things the A/B testing is used for. Yeah. But the problem with A/B testing is always it's manual. It's there's survey biases and all sorts of issues. So the real question as data scientists, that we are all interested in, how can machine learning help out in this process? You have a game that's being put together, and you have all these decisions that feed into it that affects user experience. And the real question is, where does machine learning fit in? What can we do with it to facilitate all these various processes? One of the interesting things that I really like about the gaming domain is the data quality. You have a very large amount of data, and this data is extremely fine-grained. So online games, as I mentioned earlier, they're going to collect data on individual actions. Every single action is going to be logged. And a lot of this data is unstructured. It's hugely voluminous, right? You have tables with hundreds of millions to billions of rows, right? That's the scale of data sets. That's the scale of the data set sizes you're looking at. And it's, as a machine learning scientist, it's actually quite overwhelming. You have so many pieces of information that you can use. So it's a real question of, what do I use? How do I structure this data? What's relevant, what's not relevant? So there's a lot of questions around there. And I also want to point out that this is very different from what a lot of people have been using deep networks for in video games, which is like building agents that can play games, right? So that's the other example of machine learning in video games that people are mostly familiar with, right? Can I play an agent that can play Mario, or an agent that can race a car? This is the stuff around user experience is a lot different over there. Over here, we are mostly, we are not really interested in playing the game. In a way, I would say, playing the game, it's more of a modeling challenge where the rules of the game are very clearly defined. The objectives are clearly defined. It's all about building the model that can capture the rules of the game and build good strategies. And over here, this is more of traditional data science, where I just have all these events, this huge database of events, timestamp logs, and I need to summarize this into meaningful information, which I can then use to make actionable business decisions, or I can use it to make good prediction models, which can automate a lot of my decision making. So very classical machine learning. Now let's look at a bit, how machine learning has been used so far. So traditionally, it's not like machine learning in gaming is a new thing. People have been using it for a little over a decade now. The idea is really simple. You collect data on your customer interactions, and then you build your traditional models, right? Decision trees, logistic regression. These are classical approaches that have worked well. You compile various metrics. You have your KPIs like time to return, the retention percentage, the churn percentage, right? There's a whole list you can compile, right? These are very well studied in the marketing and advertising domains, right? So some of this stuff is very well known. So let's, so what has been done? What do these approaches do, and why? What are their limitations? If we, so let's take a look at a very classic approach that people have been using to model customer engagement, right? These are called the RFM based models: recency, frequency, and monetary. And these are really popular models. That's not just in the gaming domain. You'll find these models being used pretty much anywhere where you are modeling customer engagement. These are the go-to models. There's a lot of literature out there that show these models tend to outperform pretty much any other model by far when it comes to modeling churn, right? So what is RFM? What are RFM models? It's pretty simple. You basically compile some very key metrics on engagement and recency, right? How recently did the user play the game? When was his last login? Was it yesterday? Was it 6 months ago? Was it 1 week ago? The frequency, does this guy log in once a month? Does he log in every day? Does he log in once a week, only on the weekends? How much money does the user spend on the game, right? We have users. So there are users who can spend thousands of dollars a month, and there are users who spend less than $5 every 3 months. So you have a lot of variety in your users' behavior. And then, when it comes to the world of online gaming, you can also measure time, which is another dimension you can add in, which is how much time does the user spend playing the game. So you can use these RFM style models. So you can compile these metrics. You can use them as feature sets to build your models, right? And you can use your favorite model. You can use decision trees. You can use logistic regression. You could use generative models, like some, you could use time to return gamma distributions, mixtures, which have these as features, right? You can use your favorite model. But at the end of the day, these features are going to give you very solid bang for your buck when it comes to predicting churn and telling you who's going to leave, how likely is he to leave, right? Unfortunately, this is not enough. And that's the biggest issue that the gaming industry faces, or in general, anytime you use these RFMP models, right? I can give you a list. Let's say, you are a game developer, you have a game with hundreds of thousands of users, and I come to you with a list that, hey, these are the 1,000 users who are going to churn in the next 1 month. You should do something about it. The next question they're going to come back and ask me is, it's nice you've built this churn model, but What do I do with these results? How do I use these results, right? What do I do to keep these 1,000 people with me? And that's really where RFM models have their limitations. They are not very good at telling you why the engagement is low or high. And a lot of it has to do with the complexity of engagement, right? There's just so many different factors. There's so much variety that feeds into engagement. It has to do with the heterogeneity of your population. People play a game for different reasons, right? Some of them like the competition aspect. Some people are collectors, right? They like to grind and collect all the achievements. They want the 100% collection in the game. Some people are just there for the social experience. They don't care about winning or losing. They just want to hang out with their 4 buddies online for a couple of hours and then log off. So people have different motivations when they're playing these games. And there's just so many factors that can affect an individual's engagement, right? And the nice thing is RFM summarizes all these concepts into a single quantified number, right? The recency frequency numbers, they're easy to calculate. They give you an overall summary, right? If somebody has poor engagement, he's probably not liking something. But RFM doesn't tell you what is it that he's not liking, right? That is something in the game. Maybe it's the UI. Maybe the game is too challenging for him, right? Maybe he's hard stuck. Maybe there's a game breaking bug. Maybe his laptop's not good enough to run it. There's a variety of reasons people have for these kind of for their decisions. The important question over here is, can ML help out over here, right? Help out with these factors that affect user engagement. So the point I'm trying to make is we need to go beyond the traditional RFM models, right? We need to dig deeper down to the individual mechanics of the game and find out what is it that is affecting player churn, right? You have, so some of the important factors I've listed here include toxic players. So toxic players. So these are just, this is this can be a huge list, right? We could stand here and spend hours and hours talking about different factors that affect engagement. And, I've listed just 4 things over here, right? You could have toxic players that are hurting player engagement, right? You could have people who are griefing others, abusing others, right? It's a social environment, which is a free for all as far as the communication side is concerned. So you have abusive behavior arising. There could be UI issues, right? Maybe the game has some UI issues, which is throwing off new players. It could just be the case that the game is simply old, right? It's been 10 years since the game came out, right? It's too old, people are losing interest. Or maybe the game's challenge is off, it's too easy or it's too hard, right? All these factors. And the important question is, how do we isolate these factors, right? If a user is enjoying, how do we credit individual factors? How do we credit the social experience? How do we credit the UI side? So this is a very non-trivial problem. And it's something that gaming companies really, really care about, because at the end of the day, that's what a game designer wants. He wants to know exactly what it is in his game that he needs to change or improve, right? So now, at Wargaming, right, we are constantly looking for new solutions for improving user experience and consequently user engagement. Now, this is the user engagement side. I would say there's also an ethics side to it, right? A lot of people talk about predatory practices, where you try to use, bait tactics to entice players, kind of get them to spend money. That's the wrong way of doing things. The right way of doing things would be to actually focus on improving the user experience and let the improved user engagement be a natural consequence of that process. And I would say this thing is becoming even more important in the modern gaming world, because the modern games, they are free to play, right? Which basically means the player has the freedom to purchase individual bits and pieces of the game that he likes, right? If I start playing a game for free, I like a certain character. I want to buy a new skin or a new look for that character. I could spend $1 to get that, right? I don't need to spend $60 buying the entire game, because I don't care about half the characters, right? So it's It's this new free-to-play model where you allow your customers to choose what parts of the game they like, what they want to spend money on, what they don't want to spend money on. That's been taking over the gaming industry. It's been shown pretty convincingly that the free-to-play pricing model is superior to the traditional model. Game developers make way more money in the long run using this idea. But the free-to-play model comes with these challenges, right? Where you are now forced to fine-tune individual pieces of your game, right? Because it's a lot about you want to convert customers into paying customers, and you want to see what is it that appeals to people, right? You're going to have certain items that appeal to people. You're going to have certain items that turn them off, and it's all about discovering this knowledge and then using these decisions for the right pricing, for the right offers, right? You set up your marketplace accordingly. You can set up your benefits for people who pay accordingly, right? It's a balancing act, right? You want to build a large community around your game, but you also want to make money. So the way you make money is by giving incentives or some advantage or something. You want to give something to people who pay you, right? But then you also don't want to piss off the people who don't pay you. So you're going to always have this balancing act where, are you giving away too much for how much the paying customers are, how much the customers are paying you? Are you giving away too little? There's a lot of these questions that game designers are always looking at. And, when it comes to the modern free-to-play model, these are very real problems, trying to find the right pricing options, right? Trying to tailor pricing to individual users. These are all very interesting data science problems people are looking at.
So in other domains, for example, in service industry, say airline industry, unbundling has been there. Certain airlines do that, like Spirit and Frontier. Everything is unbundled, like Southwest, like that. Bundle prices. Right? And so there's a lot of work in revenue management that focuses on how to price these different items. Right. And unlike here, it's slightly different because you can just add things. Right? You don't have any cost of adding new items. Right. But there's a set of work on like assortment planning for these things and pricing for these different goods. Yeah, I mean, I would say in comparing to the online industry, I would say the gaming industry is a lot more agile in the sense that, gamers are looking for fresh new content, right? Like if I fly 5 times. So I guess another big difference is I don't, as much as I mostly fly to get from point A to point B, right? I don't fly for entertainment, like, oh, this is such a fun experience. I'm going to buy an airline ticket. And if I fly 5 times, on the 6th time, I don't expect a new experience that, oh no, this is the same thing, it's the same seat, the same refreshments, right? You don't have that, I would say, as a customer, you don't have that luxury with airline travel. But with gaming, you can demand those things from the game developer, right? What the purchase is depend upon what is offered, right? Right. And what the price of different items. Yes. And that really is the challenge. And you're right, this is one of the main research areas, that how do you price right? So I don't know how many of you guys are familiar with Steam and the Steam marketplace. So one of the things Steam did was the elastic pricing, right? That was a big innovation. Before Steam, games were a flat $50 for PC, $60 for console, right? That was it. And maybe if it was a low budget game, then you could buy it for $20. That was about it. Then Steam came along and they said, you know what, this game that's being priced at $50, we're going to price it at say 32.5. And suddenly this game that has sold only 500,000 copies is now selling 7 million or 5 million, right? The sales numbers it's a big discrete jump in the sales numbers. So the gaming industry has figured out that, there are certain price points where you can enjoy a significant growth in the user base, the revenue. And I guess the free-to-play model is sort of the extreme outcome of this. Why don't we just give away the base game for free? And then, attract a huge population of users and then let them make the decision what they want to pay for, what they don't want to pay for. So, that's the whole new free-to-play model. And you're right, the pricing is a complex issue over there. Definitely. So
Anyway, as interesting that is, this talk, we're not going to focus on the pricing side because, well, we haven't solved that problem yet at Wargaming. So over here, I'm going to talk about a couple of problems that we did have good success with. So this is something that my colleagues and I at Wargaming, we started working on this about 1.5 years ago. So we had our data science head, he was talking about how the World of Tanks team, they felt that they have a lot of text data. So they had been sitting on this huge text data, which nobody was looking at. And there were several reasons for it, right? It's first of all, it's just huge. There's just so much of it, right? They're recording messages from users. So the real question was, okay, how can we use this chat data for something, right? This is very typical of any company, right? A company spends money collecting data. The next natural question is, can I use this for any benefit? So we noticed that we were doing very minimal stuff with the chat data, and one of the problems our live ops team, they came to us with, they said, we have a serious issue with toxic players. So World of Tanks is a player versus player game. It's a team-based player versus player game. So you have you and 4 buddies playing against 5 other people. And if anybody has played Counter-Strike or League of Legends, this is a hotbed for toxic behavior, right? You feel like your teammates are not pulling their weight, or if somebody is bringing the team down, right? It's very easy to lose your cool and start flaming him in the chat, right? So, there's a spectrum of such behaviors. It could be something like just calling out someone, hey, you're an idiot, you need to do this, and it ranges all the way to serious abuse, right? Where people, they're typing in an entire essay of how awful someone is, and they're not letting up. So it's one of the things that they really care about is, can we identify these serious toxic abusers, and is there some way to auto censor their chat or to escalate this to the chat moderators, so that we can do a better job of catching this behavior. The other problem we looked at is user feedback based upon the text they would submit. So any gaming company, you'll find there are multiple channels for providing feedback. You can have a feedback given in the form of a ticket you can raise with customer support. You can just send an email, you can leave comments on the forums. And these feedbacks, they are all over the place, right? It could be something completely irrelevant and stupid, like somebody writing first on the forum thread, like I'm the first guy, all the way to someone who says, love the game, but hate playing it, people leave comments like that, I hate this game, but I can't stop playing it, right? You have mixed messages like that. And then you have actual relevant feedback where, I'm using this particular computer settings and, I'm not able to run the game, or I face this bug, or, I think the UI is not good. So there's this huge information that's coming through all these channels. And, it's really difficult for any gaming company to just go through all of this and make sense, like what is it actually that my community wants? Because you're going to get a lot of signals from all over the place. And some of these signals are pretty contradictory, right? You're going to have a whole bunch of people tell you, wow, the graphics are amazing. And then you're also going to have a whole bunch of people tell you the graphics are absolutely awful. So it's just, it's really difficult to figure out, what's actually correct, what's not. These problems, when you look at them, they seem so disjointed. Why are we looking at toxic players and then user feedback? And the reason why I club these two together is actually we use the same model. Thanks to transfer learning, we can use the same model for both of these tasks. So let's talk a little bit about text data. I want to touch up a little bit on some of the challenges we face. So I've already talked about how users generate a very large amount of text data, and you have a variety of sentiments expressed in them. The other challenge we faced was we have multiple languages, right? We have players who speak English, who speak Russian, German, Spanish. Sorry. Yes.
So is there any other way that you collect data other than the text messages or the chats from where we are playing the game?
So we do actually collect a lot of data. So we collect individual actions. We collect, we collect anytime somebody adds them on a friends list, anytime they achieve something. There's a lot of data collected. The data collected is pretty fine grained, right? Because the developers, they want to know as much as possible about the game. So as far as the in-game activities are concerned, they collect everything down to individual shots fired by a tank. So they actually have data that, this player was sitting in this tank and he fired a shell of this type on this tank at this time instance, or, this player moved from this position to this position at this time instance. So the data is pretty fine grained and it's very comprehensive in terms of capturing what the players are doing. So the text data is just one side, one thing we looked at. But yeah, there's a lot of stuff, right? I have colleagues who are looking at things like, how players are moving around the map and, where they are shooting from. So that indicates what strategies they have. So, we are trying to build, you could say, AI tutorial for new players, right? Where, how nice would it be if an AI could look at a new player and then point out, hey, if you could just fix these, 1, 2, 3 things in your game, your enjoyment will go up from here to all the way here, right? You're going to enjoy the game way more because you're playing it better, you're playing it more properly. So, that's something gamers really care, gaming companies care a lot about, making sure that your users, your players have complete knowledge about the game. And it's actually difficult, because people are people, right? They log in, they'll use the UI, they'll start playing, right? Nobody bothers trying to go out there and actively collect information. So as a developer, you have to push that information in a very, in an easy to digest manner. So other challenges we faced were related to privacy concerns. Wargaming, we respect our users' privacy. We care a lot about it. We are completely compliant with GDPR. For those who don't know, GDPR was a data privacy law that was recently passed in Europe. And it provides a lot of, I would say, it provides a lot of benefits for you as a customer when it comes to companies collecting your data. So for example, right, you have the right to ask companies to stop collecting your data. You have the right to ask them exactly what data they are collecting. And the companies have to give it to you. You can even ask them to stop collecting data on you completely, right? There's other clauses, like if a certain personal identifiable information is not being used, then you're obligated to delete it within a certain time frame, like 2 weeks to a month. So, Europe passed these laws about a few years ago, and if you're doing business in Europe, you have to be compliant with them. So one of the concerns, we don't, even I as a data scientist, right? We want to respect users' privacy, right? It's an important part of being an ethical data scientist. So one of the privacy concerns was that even I as a data scientist should be able to work on these models without exposing myself to any information that I'm not supposed to look at. So, for example, I'm not allowed to read chat logs for players, right? I don't have the permissions to do that. So we had to build these models without looking at the actual chat logs. So, we were given examples from the chat moderation team that, this is what your input and output data is going to look like. And then we would build models and then they would run it on the data sets themselves, right? So there's, as students, you don't realize these challenges, right? You're working and you're building models and everything's nice, right? But when you move into a more corporate-like environment, you have a lot of these obstacles outside of the actual machine learning tasks that you need to deal with. So, and finally, another concern we had was, should the system be real-time or not? Right. And one of the reasons why we wanted it to be real time is because there were 2 reasons. One, we wanted it to be very responsive. If someone is being abusive, it needed to be escalated, or that guy needed to be censored right then and there. Right. There's no point in censoring someone after he's done, after the abuse has already happened. So we wanted a real-time system. So with all these challenges, we started working on a toxic behavior problem. So, we had two objectives. It was, we had a very simple directive. We want to find players like this guy, and we want to censor him right away. And if it's a repeated pattern, we want to escalate it to, a human chat moderator who can actually take further steps, like banning the player or giving him a warning about it. How did we go about this task? Now, our goal was to identify. Now, we went for this particular task, we went towards the realm of sentiment extraction. We started looking into sentiment extraction. Into sentiment extraction, and our goal was, can we build a machine learning model that can just, I give it, like somebody types in a chat message. I want to send this chat message right away to my machine learning model, and it should give me a score that, I think this is 10 out of 10 on the abusive scale. So before that chat message would get posted, the system would automatically censor it. So, the player who was being abused, he wouldn't even get to see it. So, that was one of our directives. So the real question we had was, where, how do we build this model? The challenges we faced were, even though we had a large amount of text data, the hard part was getting the sentiment label for this text data. So, these online games, you can collect the activities, but you can't collect what the person is feeling or what he's thinking, right? So, and sentiment is one of those things. It's you can't directly observe and collect it. It's something that has to be inferred based upon the chat logs and what people are expressing. And one real problem we faced over here was, how do we deal with this problem where we have the text data, we could build models to train it, but we simply do not have enough examples to train it, right? So it's that classic problem where I could use a simpler model, like a decision tree or a logistic regression, but then I'm back to that same problem of feature engineering with unstructured data, which is a difficult problem. So yeah. Oh no, I thought you had a question. Oh, okay. So we want to use something like a deep net, which is very good at dealing with unstructured data, but we don't have the volume of sentiment labels to work with it. And I'm going to talk about how we use transfer learning to get over this problem. And I also want to touch upon the second problem we solved, because we use the same model for this same problem too. So, apart from, along with identifying toxic behavior, when we were working on this problem, we had a model that could look at chat messages from users and figure out the sentiment. And one of the immediate applications we thought of the same model was, we're using it on our user interaction chat messages. Can we also use it on our user feedback to figure out what they are thinking about the game, not just about each other, right? So it was basically transfer learning on the same sentiment extraction model, and we used it for a different problem. So it's kind of like killing two birds with one stone over here. And the directive for the second problem was, as we talked about, you have user feedback, can I get the sentiment? And along with the sentiment, the other interesting twist on this was we also wanted the topic that they were talking about. So what are they thinking of and what they think about that. Now, deep networks, I'm sure you guys are pretty smart, I've heard, sorry.
Yeah, so I have one question. So you are only talking about the text data that is present in the online game. So what about the voice text message? Like we generally, like I play a lot of online games, so we generally talk to each other in the voice chats. So how are you gonna optimize that so that the abuse can be reduced in that?
So the thing in voice chat is you basically use a speech to text translator as like a pre-processing step to that. So that's basically it. And then you use once you transcribe it from speech to text, then you can use that. You can use the same model on that text.
Okay, so if I'm talking to my buddies in the grave, so yeah, the data is so the machine learning is collecting the entire thing. That
so for this particular project, we haven't done the voice chat thing, but it's pretty easy to add voice chat support. You really just need a pre-processing step, which takes the speech audio logs and then transcribes them into text data.
So generally, I usually play PUBG a lot back in the days. So whenever we have random players on the game, so somebody is abusing me on the game, and until unless I end the game, I am not able to report the player. So if something, if you have something like that, like on real time, where you can like restrict the player on from playing the game. So we generally do is like voice chat.
Right.
So how you gonna solve that thing? Like if you anytime if you're gonna solve it.
You mean like
If you
restricting the
solve
player from playing the game? Is that what you're asking about?
Yeah, straight. Like completely you're not removing them from the game.
So that's, the issue over there is, as a data scientist, I cannot make that decision, right? What do I do with the player? So that's something left to the game designer. And, typically the approach is to censor the message right then and there. That's the immediate action they take, like mute the player, auto mute him, so he's not able to communicate. And if there is a repeated pattern, then you move towards the banning phase, because banning is kind of an extreme step, right? You have people, some of them spend money on the game, they have invested a significant amount of time unlocking stuff, so you don't want to ban people for small infractions.
Okay, so will there be any warnings in general?
Yeah, they typically give you warnings. You get plenty of warnings. You have to be someone who's a compulsive abuser to get a ban. Yeah, I mean, you're throwing out a customer from your store, right? So it has to be someone who's seriously disruptive to warrant that. Basically.
And one more thing to add. So generally, if friends are talking, so we generally talk in a very free way, abusive languages. We have our own vocabulary to chat. So how you gonna avoid those kind of chats from the regular when some random person came and said me something? So how you gonna optimize that where the friends chats are very different than the person when you're playing random?
That's a very good question. So honestly, that's a hard problem in sentiment extraction. When you don't have things like, like sarcasm is a very good example, right? Yeah. You need more context apart from just the text, right? And to be honest, like even as humans, like people are bad at finding sarcasm even on the internet, right? So it's pretty hard even for a machine learning tool to do that. So you're right, that is an issue. But typically, it's typically, it's rare for that situation to be flagged, right? Because abusive behavior is a little different. It's much more aggressive language. It's repeated, right? When you are abusing, when friends are bantering, it's more of just, calling people names, right? You are not pointing out, you did this wrong and, you deserve this, something X bad for that to happen. So there are some differences. But yeah, if the text is exactly the same, it's going to be hard to distinguish. Absolutely. That's a general problem with sentiment extraction all over.
Okay, let's
sorry.
Have questions for Sahil.
Okay, yeah, all right. No, it won't take me long. So, we went with deep networks, for various reasons, most of them being that they are just very good at working with unstructured data. And I'm not going to go into how deep networks work, because I guess, you guys are smart enough to figure it out, but it's basically nonlinear functions stacked one after the other, and you start with an input, and after a bunch of nonlinear transformations, you end up with your output. And the idea is you have multiple layers. The initial layers serve as feature extractors, and the latter shallow layers are the ones that use those features to generate the predictions over there. We use attention networks. I don't want to go too much into the details, but the idea behind attention networks is they use query key value tuples. So, you're given a particular input data, that's your query. And what you do is think of it like retrieving from memory, right? You're given a memory block location, you try to find it in memory, you match it with the different blocks. When you find a match, you pull out the value from that memory block. This is basically, think of it like a differentiable continuous version of that process. Your input data is a query. You try to match it up with the different keys you have. And then, based upon the values, based upon the similarity between your query and your key, you get your values. So, I don't want to go too much into the math details. There's this wonderful paper from the folks at Google. Attention is all you need. You guys can check it out. But the idea is to learn these key value query tuples and then use those to generate predictions. Now, and one of the most popular, language text mining models has been the BERT model from Google, which I'm going to come back to in a minute. This is something we're going to make use of. It's a standard encoder decoder model, and this is the one we use as our candidate for transfer learning. So, I talked earlier about how it's difficult to find good label data for sentiments, right? So what we did at Wargaming, we had users manually label sentiment for just 1,000 examples, right? That's about how much our team could manage in a limited time frame. We then augmented this data with more benign messages. So we created a smaller data set of a handful of 1,000 instances. And then we used BERT for transfer learning. And the idea is pretty straightforward. You have these deeper layers, you freeze the weights on those deeper layers, and you retrain just the shallow layers. And the idea is, because BERT has been trained on these millions of examples, right? Millions of phrases, you just take the feature extraction part from BERT, right? What it does to take these sentences and convert it into a vector of real valued numbers, right? And it uses attention. It's all about working with word associations and finding a context for each word in the sentence. You retrain the shallow layer. So the shallow layer is what you retrain with your sentiment examples. So you take these 2,000 to 3,000 sentiment examples, and you just adjust the weights on the final layer. And this approach actually worked extremely well. And we actually found that not only did we see an improvement in accuracy, but we also found a big reduction in the time spent by the chat moderation team that they spend moderating these messages. So, so for example, the precision of abusive users flag was about 93%. So the earlier methods they were using, which involved raising tickets and humans, manually going through chat message histories, they had an accuracy rate of about 87%. And interestingly, the deep network improved upon it. So, the precision so let's say if it flagged 100 users as toxic, 93 of them were actually toxic. So that was really nice. The biggest benefit that Wargaming was...
How was the false negative?
It was pretty low, actually. The false negative rates, you could say they were largely boundary conditions where, people were calling, somebody was calling someone out, but, you couldn't really call it abuse. So like I said, right, it's when you are interacting with, right, it's a spectrum. You can be mildly, you could just call out someone, or you can be, full on abusive. So
Abuse couched as polite conversation.
I'm sorry?
Abuse couched in polite conversation.
Exactly. So, and you had cases like you talked about, right, where it was friendly banter, but people were using words that you normally associate with abuse. But overall, the system did have pretty good performance. And the one thing Wargaming was extremely excited about was that it actually cut down the employee hours that these chat moderators would spend by over 40%. So, they didn't have to go through as many tickets because a lot of messages were auto-censored. A lot of the abusive chats, the individual messages were already pre-flagged. So it was very easy for them to just go through the user's chat history and make a decision, right? So this was something that they were very excited about. And we were also able to achieve our objective of supporting multiple languages: English, Russian, German, Spanish, etc.
Do you think this will transfer over to tweets, for example?
Yeah, it should definitely. It should definitely transfer over to tweets. Yeah. I think it worked well in gaming because, when people talk in a gaming environment, they're very focused with their chat topics, versus Twitter is a lot more free flowing. So I would assume it'll be harder there. Sarcasm and issues like that would be a lot more problematic. Definitely. And then finally, the interesting part was, that's the cool thing about transfer learning. You can take a model and reuse it on related problems. So we also used, we took this and we retrained the final layer on a different sentiment data. This was sentiment from user feedback, right? This was again a small label data set. We also took the messages. Apart from extracting the sentiment, we also classified these messages across different topics. So, let's say we had a corpus of user feedback consisting of, say, 100,000 instances. So we were able to take these 100,000 feedback messages, organize them in topics. And then for each topic, we could give a sentiment score, right? So for example, we could say that 10% of all feedback from notebook users is assigned to the topic frame rate graphics, and 77% of it is negative. So, this is a signal to the game design team that, okay, we need to look at our frame rate for notebooks, because it seems there is a clear pattern or something wrong over there. So information like this is very valuable for a game designer, right? Because, so in a way, rather than relying on the game to figure out what's wrong, we are more relying on the user feedback and the text messages, which makes sense, right? Because it's a direct feedback from your customers. So, and this is all about summarizing, cutting out the noise, and putting it all together as actionable information. So overall, this experience, it was really interesting because, before this, a lot of our efforts were invested in RFM models. How can we use them? What can we do to find factors that affect user experience? But after this, we sort of changed our philosophy. We are now looking at individual unstructured data sets and trying to focus on them individually, trying to see what can we get from, say, text data, what can we get from in-game activity logs, what can we get from users' performance. So we have various teams working on these different problems, and we are making much better and even faster progress on discovering different factors that affect user experience. So yeah, and on the technical side, deep networks work really well, and transfer learning worked really well. So if you are ever in a situation where you want to use a deep network, but you don't have a lot of data, you can definitely look into transfer learning. It's a pretty useful technique. There's a lot of good open source deep nets out there for text data, for image data. Those are the two classic ones. You can find them. Yeah, I guess, if you have any other questions, it was fairly, I didn't have too much math in there. I wanted to more discuss about the gaming industry, the user experience problems and stuff. So that's about it.
And
Yeah,
Nishith,
sure.
I had a question regarding is this considered a toxic behavior where user uses mods or hacks for enhanced performance? Like if it's a first person shooting game, they might use auto aiming or stuff like that. Then how do you identify that?
So that's a very good question. So, and to elaborate a little more on your question, it's not even just hacks, right? You could just do straight up briefing. You don't even need a hack, right? You could use friendly fire, or you could intentionally throw the game. So we don't have that in the text data, so it's not able to capture that behavior. But I do know teams in Wargaming that are working using the activity logs that are focusing on that particular problem, right? We have data on where users were on the map, when they fired their shots, how did they perform. So that kind of data is very helpful to inform, identify situations that you're talking about. Definitely.
back to the question of the domain generalization. So this thing of toxicity classification, one important question is how do you look at different communities?
Right.
Different communities are different, let's say, modes of operation.
Right.
For lack of a better word. So there's new trend that is coming in machine learning, the invariance, risk invariance for domain generalization. Like I have some work on that last year. So there the whole idea is to you actually make your classifier robust to the spurious correlations that appear in the feature sets that go into different environments.
Okay.
And you don't seem to be using those techniques, but
no,
it seems like on an average, it does well.
Mhm.
It may penalize certain communities more than others. So the question of fairness does appear. Certain communities may be flagged a lot more for the
That's-
language.
Yeah, I mean that's a very that's an interesting observation. I think the reason why it was not such a pronounced problem in our situation was we had a natural segmentation from our data set because of the language support. So we had, like the Russian community, their model was separate from the North American community, which was separate from the German community because the models themselves had to be more language specific. Having said that, it would be interesting to try something like that and see if it has a noticeable improvement on the results. Yeah, that's something we haven't tried with this model.
Also, basic, even within the Russian community, the sub-communities that exist, and looking at the performance of classification across communities, what is the variability? Should be something.
So I think there wasn't. So I don't honestly have the numbers for the community-wise breakdown. I do know that the model performed the best on the Russian community, and I think a lot of it has to do with it is because we just had more data for the Russian community. So
which language had the most colorful users?
Russian. They are the most hardcore. They are very serious about the game, right? North America has a lot more casual. So that's the big difference. North America has more casual players, so there's less abuse. There's fewer examples versus Russia, which is, they're super hardcore. They take the game seriously. And they just have a much higher skill level. So if you're a newbie, you're going to get flamed. You could just get flamed for the tank you select. Oh my God, why are you playing this tank?
So is that a trend you noticed even within languages that more experienced players have more instances of abuse?
Definitely, yes. There's a big section of the veteran player community, that they're serious about the game. They play every day. They care a lot about winning. And they don't like it if there's a newbie in their game throwing a match. So they let the person know what he's doing.
So games are something like you don't have boundaries between the regions and you can actually play with anybody in the world. So let's say in case of classifying the words like toxic and non-toxic, so people will be, to my observation, whenever I play, so more than the chart that we do, because it's a gaming, right? So we always feel like interacting with them directly and asking them to come and do some certain things. Like let's say I'm playing with some 100 people. So out of 10 people are my friends. And I know different languages. So I try to use different languages to communicate with my friend more than the chat. So what you classify here as toxic may not be the thing, because in gaming world, we will mostly use words these days. So how do you actually work it out? The vocabulary way of removing the toxicness.
Like how the vocabulary reflects the
It can be a
toxicness?
single language, it's okay that you can actually do it. But if it is a mix of multiple languages and totally based on only vocabulary, it's like more of voice-based things.
So that's a good question. So one thing is, you can look at the BERT model, family of models, to answer this question. So they do have a separate model for English because they just have so much data for the English language. I know they do have a model which supports multiple languages. And the reason why that works is because even though you have different vocabularies, at the end of the day, the model is agnostic to that, right? It literally works with tokens, right? That's how text mining models work, right? Words are treated as tokens, and you look at which token appears with what, right? That's really the basic idea, basic observation they use to find out the context, build these, assign these numerical vectors to context. So, even if you're supporting multiple languages, you're not going to have a token from a Japanese word appearing with the token from from the German vocabulary. So even if you're supporting multiple languages, the model will still learn that, the Japanese tokens appear together and the German tokens, vocab tokens appear together. So it's not going to mix and match. So it kind of is taken care of in the model training part. That's the neat thing about deep nets. So you don't have to worry much about a lot of things.
So there is also a reception now. So maybe we can take questions at the reception. We can have some personal time with the speaker.
Absolutely.
Let's thank the speaker.